Now let's talk about type system. Very simple type system. To talk about type system, we need to pick a language, and today's language has 9 language constructs. And as you can see, it has 3 kinds of values: numbers, booleans, and closure V. We have the usual addition and subtraction, and we do have multiple parameters, right? Functions with multiple parameters and function call with multiple arguments. Because I'm lazy, I just use this notation, which is either it takes no argument or it can take many arguments separated by comma, and function calls as well, meaning that it's like it can be like this, that, or e comma e, e comma e comma da 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 e. Okay, and if expression has 3 sub-expressions. Let's write down types for these expressions. Primitive things first. You know, numbers have num type. Now we have this type called NUM, num for numbers. True, it's a Boolean type. And when we have an expression of 1 plus 2, we said that those primitive values have types. A type is a set of values, or a type represents some properties of expressions. And types are really interesting. It has many powers. And when we have a set of values, we can categorize that, classify them, split them depending on their types. And num for values, set of values, num meaning a set of number values. Bool is really interesting because its value set has 2 values, true and false, right? 1 plus 2 is an expression. What's the type of this expression? In order to know the type of a complex expression, we need to split that expression to smaller parts, meaning that it's an addition operator, and we have 1 and 2. All we know is that addition is a function which takes 2 numbers and produces a number. We know that 1 is a number, 2 is a number. Oh, that's good, because addition expects 2 numbers, and we got 2 numbers, right? So it's gonna be what? Number. That's how we get types of complex expression. 1 plus false. Yeah, all we know is that addition is a function which it predicts 2 numbers, produces a number. It's a promise or contract. 이거는 어떤 계약이에요. All it says is that if you give me 2 numbers, I promise to give you a number back. But if you do not give me 2 numbers, I don't promise anything because you broke the promise. Yeah? So when we gave 2 numbers, it gave us number. When we give 1 number and a Boolean, this addition operator didn't say anything, right? It does not promise anything about a number and a Boolean, so it's gonna be an error. No type error. So far so good. So we can have rules for that. Typing rules, type rules, meaning any number, 1, 42, 8, 77, whatever, any number has type num. True and false, they have type bool. When we have E1 plus E2, we need to check, just like we saw before with the examples, we need to check whether E1's type is number. We need to check whether E2's type is number. If both of them are numbers, then E1 plus 2 is number. Okay? Right? Now that we have these rules, we can check the types. Like, 1, it's because 1 is a number, it has type num. True, we have this rule. So true, yeah, it's types full. What about 1 plus 2? Oh, that's E1 plus E2. There's one rule to apply. So we need to split that to 2 sub-expressions, 1 and 2, and check whether they have num types. Oh, that's good. So this one is going to be num. How about that? 1 plus false. Oh, it's a plus thingy. Then there's only one rule to apply. Then let's see. E1 and E2. E1 and E2. 1. Oh, I know. It's number. False. Oh, I know. It's Boolean. Oh. That does not match. Because it expects two numbers, but I have a number and Boolean. Then we cannot say num here. It's going to be an error. Are you with me? Actually, these rules are not yet correct. They're going to be fixed later. Okay, but so far, let's just assume that we do not have any environments here. We are going to add environments to here so that you can say under some type environment, number is a num type, like that. But we are going to extend that later. Until then, just to see how we define type rules and how we use type rules. Okay? Then, when we have some complex expression like this, it's an addition of two sub-expressions. So we need to split that. 1 plus 2, that's an expression. 3, that's an expression. 3, oh yeah, we know it's number. 1 plus 2, yet another occurrence of addition. Then we need to split that one more time. 1, number. 2, number. So 1 plus 2 is a number. Then 2 numbers, this is a number. This is called what? Type derivation. Type derivation. When you have a set of typing rules, when you have some expression, you should be able to write down this type derivation. So you're going to see that in your final exam. I will repeat this in Korean and again in English and move on. 파이널 exam에서 타이핑 룰 셋을 쭉 주고 뭐 expression도 언어가 뭐 다르겠죠. 거기 타이핑 룰을 주고 어떤 expression을 준 다음에 type derivation을 그리세요 할 거예요. 그럴 가능성이 매우 높아요. 그러면 타입이 있을 수도 있고 에러일 수도 있겠죠. In a final exam set, we may have some weird expression L. It may have some language constructs, like several language constructs. We may give you some typing rules and give you some expression and ask you to write down type derivation. Let's try more examples. Conditionals. When we have this if expression, it has three sub-expressions. E1, E2, E3. All we know is not true. Yeah, that's an expression which happen to be a value whose value has type bool. 1 and 2, they are num. So, yeah, if expression expects a Boolean value for the conditional expression, that E1. And for E2 and E3, which branch it is, whether it's true or not, both are numbers. So we can safely say that the type of this whole expression is num. Yay, clean. How about this? Oh yeah, if expression expects a Boolean condition, but this is a number, I would say it's an error. How about this? Oh, if expression now it has a Boolean condition, that's good. But true branch has a number, first branch has a Boolean. Meaning that depending on the value of condition, this whole expression may have type number or Boolean. What do you want to do with this one? That's interesting, right? You may say that, hey, we are smart. We know the value is false. So it's going to be always this one. The whole expression is going to always evaluate to false. So the type should be Boolean. Yeah, you are smart, but you are not correct. Meaning that we'd like to know the type before evaluation. We said without evaluating. Right? Without evaluating, you don't know whether its value is true or false. All we know is it's Boolean. What do you want to do? We don't know whether it's a number or Boolean. What's going to be its type? One simple answer is going to be no type. You know, there's no type for num and bool. In this course, we may have several type systems. Today's type system is going to be really primitive in the sense that we're going to reject that. Oh, there's no type that's both num and bool at the same time. In some advanced programming language, we may say that, yeah, it's perfectly fine to say num or bool. It's a union type. Num or bool, not string, not other types, but num or bool. Very precise, right? Or you can say, one can say that there's a type hierarchy saying that num is any type. Bool is any type. So we can say this is going to be any type. Depending on the type system, there could be some type errors or not. And we call that expressiveness of the type system and the language. We can discuss this later, but today, because this is the first lecture with types, we are going to be really simple, saying, hey, two branches have different types, it's an error. 아주 간단하죠? We are going to extend this type system to be more expressive later, not today. So, then what's going to be the type rule for that? When we have if expression with 3 sub-expressions, the type of the first sub-expression is going to be Boolean because that's the condition expression. We don't care what the type of E2 is. E2's type could be num, bool, some arrow type, I don't care, but some type tau. Then, all we want to say is the type of the third sub-expression should be the same type, right? That's all we want to say. Then the type of the whole if expression is tau. We may want to say this. If E1, E2, E3, what's the type of this expression? You know what? E1's type should be Boolean. E2's type is tau. E3's type is tau prime. Then tau should be the same with tau prime, and then we say tau or tau prime here. They are just the same rule, just different notation. So far so good? Yeah? Then let's write down that typing rule. Let's apply typing rule for some specific examples. When we have if true E1, E2, E3, we are going to say E1's type is Boolean, E2's type is num, then E3's type should be the same thing. They are just the same. Then that's going to be the type of the whole expression. Okay, how about this one? E1's type is num, error. Because E1's type should be bool, we can say no type. How about this? E1's type is bool, so far so good. E2's type is num, so tau is num. E3's type is bool. They are different, no type. Okay, are you with me? Yes. So until now, we talked about easy things like numbers, addition and subtraction, booleans, and if expressions. Then, what's gonna be a difficult one? As you see, right? As usual, that's gonna be functions, right? Functions, variables and functions. Then, identifier, x, that's the whole program. What's the value of x? Do you remember? What's the result of interpreting x? Yeah, free identifier error. Then what's the type of x? No type, I don't know. It doesn't have any type. Then, how do we know the type of x? How did we know the value of x, right? Yeah. How do we know identifier? When it is introduced as a function parameter. X is introduced as a function parameter, so when we introduce a name, we need to introduce its type as well. It's called type annotation. 타입을 붙여주는 거예요. Type annotation. When we introduce a name, we need to introduce its type as well. Then, yeah, x's type is Boolean. Okay, it's a function which it takes a Boolean, and the body expression is what? X. What's the type of x? Boolean. So, the type of this function expression is what? is a function, so arrow type. Arrow type whose parameter has type Boolean, whose body has type Boolean. So far so good? Yeah? One more example. Okay, it's a function expression, so it should be an arrow type. Its parameter has type Boolean. What's the type of its body expression? Let's see, it's an if expression. Okay, what's the type of E1? That's X, whose type is Boolean. So far so good. What's the type of E2? That's num. What's the type of E3? That's num. Oh, good, it's well typed. So the type of the whole expression is going to be num. So what's the type of this function expression? It's an arrow type from Boolean to number. Yeah? Is it clear? That's good. Then, let's generalize what we saw by now. When we have an identifier, what's the type of it? We need to look up the environment. That's why we need to extend the typing rule to have environment, type environment. When this type environment has type information about this name, right? Then we are going to look up the type environment to know its type. Look up the environment. When we interpret X, what did we do? Look up the environment. When we type check this name X, what do we do? Look up the type environment. When we interpret this X under sigma X is gonna be, its value is gonna be sigma X. Remember, right? Look up the environment. When did we put the value of X into the environment? Function call, right? But in a typing rule at compile time, when do we put the type of identifier into the environment, type environment, at function definition? In this function expression, when we introduce an identifier, we should introduce its type as well. That's the syntax, right? Now the syntax and body expression. What's the type of this function expression? In order to know the type of the function expression, we need to check the type of the body expression, just like we did with this example. So, in order to know the type of the body expression, we need to extend this type environment with these parameters type information. Get the type of the body expression and make an arrow type from parameter type to return type. Are you with me? That's the difference. At runtime, when we interpret X, let's just put the type information as well. What's the value? We do not even look at the body expression. We just make lambda X dot E, comma, sigma, closure V. We do not even look at the body expression. But when we type check this lambda expression, we need to type check the body expression to get the type of the body, meaning the type of the result, to make type of this lambda expression. Okay? So far so good? Then, let's apply these rules to real code examples. X under empty type environment, what's the type of X? Oh, I know nothing about this name, so it's a type error. Okay? When we have this function expression, what's the type of this function expression? Under this empty environment, what's the type of this function expression? Oh, let's look at the typing rule. Under given environment, what's the type of this function expression? In order to know that, we need to know the type of the body expression. We need to know the type of the body expression. On the rich environment, extend the given environment with this information. Extend this given, it's empty, okay. Extend what? Parameter has Boolean type. Okay, with this extended environment, what's the type of the body expression? Oh, X, look up the type environment, that's bool. So, the type of this function expression is parameters type Boolean to type of the body expression. Okay? Okay. Oh, one more example, a slightly more complex. expression. Let's say, oh yeah, we have this, the same thing. So I'm gonna skip that. So under this environment, what's the type of this body expression? It's slightly more complex. We know the typing rule for if, which is not here. So X's type should be Boolean, U1's type should be num, E2 type should be num, they should be the same, then the type is gonna be that. So we know that this lambda expression, it's an arrow type from parameters type to bodies type. Yeah? Okay, then let's revise the rules, right? Let's revise the rules. Then we have all those usual thing with this gamma extended. Okay? Are you with me? Then function calls, again, that's gonna be the most important and most, just highlight of typing rules, as usual. This is a function expression. We just did type checking. Its type is Boolean to num. Argument expression is Boolean. Oh, that's good, because this function expression expects Boolean, and when we keep the promise, give Boolean, it's gonna give us number back. So it's gonna be number. How about this one? Again, this one expects a Boolean. If it gets a Boolean, it's gonna give us number back. But we gave it a number. What? It expects a Boolean, but we gave it a number. Error. How about this one? Wow, it's a function call. Function call syntax. And the first of all expression has a number. It's like adding number with a closure V, right? Calling number, error. Okay, then, what's the typing rule for this case? When we have E1, E2 function call under some environment, we need to check E1's type. And E1's type under the given type environment should be an arrow type. We don't care about its parameter type or return type, but it should be an arrow type. Okay? And then we need to check E2. We need to check the type of E2. This time, E2's type should be the parameter type of that function type. If that all matches, then the type of function call is going to be the return type. Right? So far, so good. Let's apply that. This time, it's a function call with function part and argument. Because the lack of the space and because I'm lazy, I skipped this, but you need to write it down. Again, this is a type derivation till the bottom. We didn't do that here, but you need to do that. If you don't finish till the bottom, then you're gonna get some penalty. 타입 데리베이션 끝까지 그리셔야 돼요. 자리가 없기도 하고 내가 게을러서 안 그렸는데 여러분은 파이널 에그점에서 안 그리면은 감점이에요. Okay, so this one expects Boolean. If it gets a Boolean, it's gonna produce a number. It got a Boolean, so it's a number. What about this one? Again, it expects a Boolean, produces a number, got a number, no type. Right? These are typing rules. Oh, one more time. What? Again, let's apply this one more time. Under a given environment, under this empty environment, we have E1 open, E2 close. We have E1 open, E2 close. Syntactically correct. Well-formed expression. Let's type check it. Then we need to type check E1 under the same type environment. We need to type check E1 under the given environment. We also need to type check E2 under the given environment. We need to type check E2 under the given environment. E1's type should be tau1 to tau2. E1's type is number. E2's type, whatever. E2's type is number. Actually, not whatever. It should be the type of the argument, but it's not. There is no argument. Type error. Okay, this is how we apply typing rules to write down type derivation. We'll stop here and take the second break.